Hey there, welcome back again. We are taking a look at lesson 3 using rules of exponents. Our objective during this lesson is to learn about exponents, including negative exponents, the product rule, the power rule, and then we'll also take a look at the division rule or the quotient rule of powers. We'll also rewrite numbers in scientific notation and then find products and quotient using the exponent rules and scientific notation. Starting out, we'll take a look at our exponent rules. First, we'll define what an exponent is. It tells you the number of times that a base is multiplied out. So for example, if you have a 3 to the 5th power, the 5 represents your exponent, and then that tells you you're going to multiply 3 5 times. So we do 3 times 3 times 3 times 3 times 3, which gives us 243. Secondly, negative exponents. So negative exponent is when the number in your exponent position is negative. And what that means is that your power is going to flip from the numerator to the denominator or vice versa. So if we have x to the negative n, that is going to be equivalent to 1 over x to the n power. Let me zoom in a little bit so you can see that. So x to the negative n, what that means then is that you have a negative exponent where that n is, and that means that your power is going to flip into the denominator and become a positive exponent. So 1 over x to the n. When we rewrite our exponents using these rules, we're always going to rewrite them using positive exponents. So we will use that negative exponent rule quite a bit. So using our negative exponent, we are going to simplify the following results. And a couple of rules that we're going to use. So x to the negative n is equivalent to 1 over x to the n. So I'm rewriting it as a positive exponent. If your negative exponent is in the denominator, and 1 over x to the negative n can be rewritten then as x to the positive n. So looking at that, we see that in this first problem right here. So 1 over 5 to the negative 2, since that negative exponent is in the denominator, I'm going to rewrite that as a positive exponent in the numerator. 5 to the second is simply just 25. In problem 2, I have a base of 5 to the negative 2. Again, I'm going to rewrite that as a positive exponent, 1 over 5 to the second power, which we just did 5 to the second power, which is 25. So I'm always going to rewrite these using positive exponents. Here we have a negative 5 to the negative 2 power. Now, since we have this minus sign out in front, that just means I'm talking about this whole power being negative. So my answer then is also going to be negative. So I'm going to have a negative, and then it's going to be 1 over 5 to the second power. Now we've already done 5 to the second power, that's 25, so this would end up being negative 1/25. So that first step always is rewrite that as a positive exponent. Continuing to D. Now D is a little bit different than C. You should notice that there's parentheses around that base. So that means our base is actually negative 5. So when I rewrite this one, I'm going to rewrite that negative 5 as my base. That's going to be 1 over negative 5 squared. And again, I just rewrote the negative exponent in the denominator as a positive exponent. And negative 5 times another negative 5 actually turns to positive, so that'll be 1/25. So the difference between C and D was that in C, this negative sign out in front was telling me the whole power is negative. In D, it's telling me to use negative 5 as my base and then multiply that out according to the exponent. Now, E is kind of a combination of both, but what's really going to happen is since we have this negative out here, that means the whole power is negative, and then I got my negative exponent. So we're going to be 1 over negative 5 to the second power. And this is one we've already done. It's still 25, but this negative sign that was out in front coming from here comes to here and also goes to there. So we'd have a negative 1/25. So using that negative exponent, we can rewrite using positive exponent, and that's the way our answers are going to have to be in their final form, is with positive exponents, and then if possible, we'll simplify those out. Next, we'll take a look at the product rule for exponents, and one thing to keep in mind is that product means to multiply. So when you multiply x to the m power times x to the n, to simplify that, you can rewrite that as x to the m plus n. So you can rewrite a product of two powers with the same base by adding their exponents. And then the division rule for exponents is also called the quotient rule. So quotient means division. The quotient rule of division is x to the m over x to the n is equivalent to x to the m minus n. So you could subtract those two exponents. Then below here, we'll use those two properties to start to simplify these powers down below. Focusing in on part A here, we have a product of all these powers. So we are going to use the product rule of powers. And I'm going to start to look at using the commutative property, starting to get the x's together, because I can use the power rule with the x's, and then I could use the product power rule with the y. So I'm going to start to organize them using the commutative property first. So now I've used the commutative property to put the x powers together, then also the y powers. One other thing we may see is that you just have a plain y. If you have a plain y, that just means it has a power of 1. The next thing I'll do then is use the power rule. So I'm going to start to product of powers rule. I'm going to start to add together the exponents. So now I'm going to rewrite each of the x powers and y powers as one single power with the exponents added. So now I have taken the red x powers and rewritten them with the exponents being added together, and then also the blue y powers have all been combined to add those together. So the next thing I'll do is I will add up the exponents. So 2 plus negative 3 would be negative 1. Negative 1 plus negative 5 would be negative 6. For the y's, I would take negative 4 plus 2, which is negative 2, plus 1, which is negative 1, but then minus 2 again would bring me down to negative 3. So now I've rewritten them with the one single power, x to the negative 6, y to the negative 3. And both those are negative powers, so we do have to apply the negative exponent rule, We're going to go 1 over x to the 6th and y to the 3rd. So all in all, there would be everything written with a positive power exponent, and there would be our final result. So similar to the last problem, I'm going to get all of my x's grouped together using the commutative property and all my y's grouped together. And I find it helpful if you do have two different colored pens, you can write them in different colors to keep them visually separated. So the next thing I'll do is take the exponents, and when I'm multiplying all those x's together, it's equivalent to do just adding up all of my exponents. Same with my y's. I'm going to add up those exponents when they are being multiplied together. So when I take my exponents for my x, I add them up and I get x to the 2nd, x to the 3rd down here. When I add up my y's, 2 plus 1 is y to the 3rd, negative 7 plus 4 is negative 3. Next, I get to the point where now I'm dividing my two powers at the same base. So from up above here, I know it's kind of hard to see because I've kind of scrolled down, but now I'm going to subtract my numerators, exponent, and my denominators. So I'm going to take first x to the 2 minus 3, and 2 minus 3 is negative 1. So that's going to be x to the negative 1. And then my y, I'm going to subtract my numerator minus my denominator. 3 minus negative 3. So just really quick down here, I'm going to go 3 minus negative 3. Anytime you subtract a negative, that's like adding. So that's going to be y to the 6th. And since my x is raised to a negative power, that's going to go into the denominator. So my final result then, I'm going to have a y to the 6th up in my numerator over x to the first power. And there would be my final result. So we do have a lot of steps for that problem, but as we work through each of those rules, we will get our final result, y to the sixth over x to the first. Our last power is the power rule for exponents. It says that anytime you have a power raised to an exponent, to simplify that, you can multiply your two exponents together. And similarly, if you take a product x times y and raise it to an exponent, that exponent is going to be multiplied to both exponents of x and y. Where here x and y each have an exponent of 1, so x is raised to the n, and then also y is raised to the n. So we will use all three power rules plus our negative exponent rules to start simplifying a. So we'll start to talk about that next. So our 2 right here is this power outside the parentheses, and we are going to multiply it by the x exponent and the y exponent. Same thing here, we're going to take -3, multiply it by the x exponent by the y exponent, and then this 3 is going to multiply to the x exponent and the y exponent. So we're going to make a new fraction over here and use this power rule to get rid of all those parentheses and using those exponents at the same time. So in this first problem here, this first part, we're going to take this 2 and hand it out to the x, and that's going to make it x to the second power. Then we're going to take that 2, since it's y to the third raised to the second power, we are going to multiply 3 times 2, and that's going to be y to the sixth. So I'm going to go through with the black and the red and continue to simplify the rest of these. So there I've used the power rule to get rid of all the parentheses. The next thing that I will do is start to use the commutative property to get all my x's and then add their exponents, and then get all my y's and start adding their exponents. So I'm going to do that next, and I'm going to make a new fraction bar again. So my next step, now I've taken the exponents and got them ready to add to start to simplify. So I'm going to add up all the exponents of x, all the exponents of this y, all the exponents of this x, and all the exponents of that y. And then I'll rewrite it in another fraction here, simplify it out. So now I've got all my exponents added up. I've got an x to the fourth, y to the third, x to the seventh over y to the negative fourth. So now the last thing to do, if we can see, we've got this x to the fourth over x to the seventh. We're going to subtract 4 minus 7. And then we're also going to subtract 3 minus a negative 4, which, remember, when you do 3 minus a negative, that's going to be like adding. So 4 minus 7 first is going to give me x to the negative third. I'm just going to rewrite it over here. Got a little bit of room. And then 3 minus the negative 4 is like 3 plus 4, which is y to the seventh. And lastly, I have an x to the negative 3, so that needs to go down into the denominator. So my final answer is going to be y to the seventh over x to the third. And there would be then our simplified answer with all positive exponents. And I just realized I made just a tiny mistake. This I used as an x to the third, it was a y to the third. So I am going to change that, and then I'll show you the results. Okay, I went ahead and fixed that, so made that y blue, which is going to cause my x's to have 4 now, so x to the fourth power and then y to the negative 1. Now we're ready to subtract. 4 minus 4 is 0, so that's going to give us x to the 0 power. And 3 minus the negative 1 is y to the fourth power. So again, y plus, or 3 plus 1, excuse me, is y to the fourth. Now, an interesting note in math, x to the 0 power is actually 1. So all in all, our final answer is going to be y to the fourth. So I apologize for that. I'm going to try to get a note on there to allow you to skip ahead. If you did, great. If not, I apologize. So we'll finish up with part B, where we're going to also use our power rule. So we're going to take our 3. Our 3 is going to be handed out. And then also this 2 right here is going to be handed out. So we'll start by rewriting those first 2 using our power rule. So taking that 3 and handing it out to the 2 and the x, I'm going to get 2 to the third, x to the third, and then taking that 2, handing it out to the 3 and the y, I'm going to get 3 squared y squared. Now here's our first case where we've got some numbers, so I'm going to simplify these. 2 to the third is going to be 2 times 2 times 2, which is 8. 3 to the second is 3 times 2, which is 9. So we're going to simplify that part next. Anytime we have numbers, we're going to try to do that. After we do that, we'll see it looking like this. Next, we'd look to see, is there any powers I can multiply together at the same base? There's not, because this is just an x to the third up in the numerator. Y squared, x squared are different. I can't multiply those together. But there is an x to the third over x squared. I can subtract those exponents. So when I do that, I do 3 minus 2, which gives me an x. So I'm going to have 8x. So 3 minus 2 is 1, x to the first, or x, same thing, 9. And then I still have my y to the second down in my denominator. Then I'll check, are there any negative exponents? No. 8 and 9, can those be simplified as a fraction? They cannot. So that would be my final result. And this would be the end of the video for day 1. So we've met our learning target of using the power rules to simplify expressions. Welcome back to day 2, where we are going to look at the second half of our learning target, which is converting numbers to scientific notation, and then also finding products and quotients of numbers that are in scientific notation. So first, scientific notation is a method of writing a number as the product of a number greater than 1 or equal to 1 but less than 10, and then a power of 10. So it's basically a shorthand way that we can rewrite numbers. And we're going to take a look at a couple of numbers and then talk about how we can rewrite them using scientific notation. So we're going to look at rewriting two numbers in scientific notation. The first number is 200 billion, and that's been a number that's been in the news because that is the net worth of the owner of Amazon, Jeff Bezos. It just came out recently. He's the first person to make $200 billion. So anytime we want to write a number in scientific notation, we are going to first make the number a number between 1 and 10. It can't be 10, but it has to be less than 10. But to do that, we're going to take where the decimal point is. So the decimal point of this number would be right here. And we are going to move it until we make it a number that's between 1 and 10. And that's going to be this number 2 right here. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. And if you kept track of which direction I was moving to the left, and that's going to make the power increase. So to rewrite this number in scientific notation, it would be 2 times 10 to the 11th power. And there's the two parts of scientific notation. Here's my number between 1 and 10, and then here is my power of 10. So that would be 200 billion rewritten in scientific notation. The next number is 0.0039, and this is representing 0.0039 inches. So if you want to take a second to think about that, but that would be the thickness of paper. So now we're going to rewrite this in scientific notation. To make this a number between 1 and 10, I'm going to put the decimal point right here. So I'm going to move it to the right 1, 2, 3 times. So I moved it to the right 3. Now it became 3.9. And then anytime I move to the right, my decimal point decreases. So from 0, that decreases 3. So that's going to be times 10 to the negative third. So there would be my two numbers rewritten into scientific notation. Lastly, we're going to look at two examples where we can find the product and quotient of numbers using scientific notation. We're going to use things that we have talked about in the last two lessons. We're going to use the commutative property, and we're also going to use the product of powers rule and the division of powers rule, which we talked about earlier in this lesson. So first, the commutative property. We have number parts, so 4.2, and then I took 0.0028 and changed that to scientific notation. Those two number parts we can multiply together, and then also these powers of 10 we can multiply together. Then the same thing down here. So I'm going to rewrite this using the commutative property and start to show how we can multiply this out. So I've used the commutative property to put the numbers together, 4.2 times 2.8, and then to put the powers of 10 together, and same as the denominator. So I'll use a calculator. I'll take 4.2 times 2.8, and that gives me 11.76. And then I'll also take the powers of 10, 10 to the negative 7 times 10 to the negative 3. Since they have the exact same base, I'm going to add negative 7, negative 3, which is 10 to the negative 10. So I'm just using that product of powers. Since they both are bases of 10, I can add those together. Secondly, I'll use my calculator to do 2.4 times 1.6, which is 3.84. And then the powers of 10, I'll take 3 plus negative 10, which is 10 to the negative 7th. Okay, next thing I will do is I'm going to start to use division. So we're going to make a new fraction over here, and then we'll start to divide my number part, and then use my division of powers rule to divide my powers of 10. So I'll use my calculator again. I'm going to take 11.76 divided by 3.84, so I can divide the two number parts using my calculator, and I'm going to get 3.0625. And then dividing my two powers of 10, since they're the same base, I can subtract their exponents. So this is going to be negative 10 minus a negative 7. When I take a negative 10 minus a negative 7, that's like adding. So that's going to be negative 10 plus 7, which is 10 to the negative third. And I have my answer in scientific notation already, 3.0625. The 3.0625 is between 1 and 10. And times a power of 10. So there's one method to multiply and divide, or find the product and quotient of scientific notation. For example 5, I'm going to show you an alternate way using a graphing calculator. So we'll take a look at that in example 5. Example 5, the maximum distance from Earth to the Sun is 152 billion meters. How many seconds does it take light to reach Earth from the Sun? Give your answer to the nearest hundredth. So we have 152 billion, kind of similar to that number we looked at above, the 200 billion. We're going to rewrite this in scientific notation. So I'll move it over 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to move it over 11 times. So that's going to be rewritten as 1.52 times 10 to the 11th. I moved it 11 to the left. That increases my power by 11. And I want to know if the speed is 3 times 10 to the 8th meters per second. How long does it take that light to get here? Well, I want to figure out then how many times does 3 times 10 to the 8th go into 1.52 times 10 to the 11th. So if I want to find out how many times it goes into, I'm going to find the quotient, which is going to be the divide. So there is the scientific notation of my distance from Earth to the Sun, and then also how fast light is going. Now I'm going to divide those. So next thing I'm going to do is pop up my calculator and then show you how we can use our calculator to solve this problem. So in your calculator, you do have a fraction button, and I'm going to use this quite a bit as we go throughout the year on these video notes, but you're going to hit alpha, which is this green button, and then hit your y equals. It's going to open up a menu. In that menu, you're going to select the very first one, which is a fraction, numerator and denominator. Next thing is we're just going to put in our scientific notation. So here's our distance from Earth to the Sun, 152 times 10, and then from last section, our power button is this caret times 10 to the 11th over 3 times 10 to the 8th. And I went kind of fast there, but you can just hit down arrow to get down into your denominator. After that, you can hit enter, and we get 506.6 repeating. It says round to the nearest, how much does it say here? Round to the nearest hundredth. So we're going to say that's about 506.66 repeating. So it's 6 and then another 6, which the next number is another 6. So that's going to be 5.067 seconds. And if you take that and divide that by 60, that would be how many minutes it takes. So 506 divided by 60 is roughly, that's about 8, a little over 8 minutes. So it's roughly about 8 minutes. So it takes sunlight about 8 minutes to reach Earth. So technically, if the sun did burn out, it would take us about 8 minutes before we would realize that the sun was in fact burned out. Now I enjoy using the calculator. It makes the math pretty simple. So again, if you need to, you can go back and look at the key sequence, but that fraction button is something we'll use quite a bit throughout the year, so make sure you get familiar with that on your calculator. So that is it for day 1 and day 2 of lesson 3. We have gone through the exponent rules with powers, and then secondly, we looked at converting numbers to scientific notation, and secondly, finding products and quotients of scientific notation. We'll see you next time.